Hello, I'm Thomas, and I will introduce our work called ScoreNet, Learning Non-Uniform Attention and Augmentation for Transformer-Based Histopathological Image Classification. This is a joint work with my colleagues Behzad Bozorgtabar, Antoine Spahr, and Jean-Philippe Thiran. We have two main contributions. The first one is an efficient transformer-based architecture for the classification of megapixel histopathological images. The second one is an augmentation strategy to create new training examples by carefully mixing existing image label pairs. The ScoreNet architecture is motivated by the observation that standard deep learning models are ill-suited for megapixel images and that a multiple instance learning approach is suboptimal as it is not end-to-end differentiable, which implies that the embeddings of the local patches are independent of the global representation and label. On the other hand, the motivation behind ScoreMix is that existing augmentations either create locally ambiguous images or risk creating mislabeled samples by cutting non-discriminative regions in the source image or pasting upon discriminative one in the target image. ScoreNet exploits the redundancy in histology images and only processes a fraction of the input image in high resolution. As the discriminative region might be small, we cannot sample patches at random, and we therefore propose to learn the sampling distribution online. For that purpose, a downscaled version of the input image is fed to a scorer model, which highlights the most relevant low-resolution patches. We then use the differentiable top K operator of Jean-Baptiste Cordonnier et al. To select the corresponding high-resolution patches. These patches are first individually embedded with a transformer model, referred to as the local fine-grained attention model, and then they attend to one another with a global coarse-grained attention module to get the image representation. Importantly, global shape cues or tissue-level features can be incorporated to the global representation via the scorer model. Following the same intuition that motivated ScoreNet, namely that the semantic content is not uniformly spread on the images, we devised ScoreMix. ScoreMix is an augmentation strategy that creates a new training example by mixing a pair of source and target images. A discriminative region is cut from the source image and pasted in a non-discriminative region of the target image to mitigate the issue of creating mislabeled samples. When used in conjunction with ScoreNet, we use the output of the scorer to determine the cutting and pasting locations, but it can also be used with the self-attention of a standard DIT. Among other experiments, we tested the proposed method on a breast cancer thyroid classification task and reported excellent results. Most importantly, these results were obtained without the need of a pre-processing step and with an architecture having a significantly higher throughput than the existing methods. To conclude, we propose ScoreNet, an efficient transformer-based architecture tailored for megapixel histology images. Along with it, we devised a mixing augmentation strategy that is based upon the same underpinning principles. These contributions were thoroughly tested and yielded state-of-the-art results on the BRACS classification task.